Hello everyone, welcome again in this video. So yesterday guys, I was talking about some couple of formulas that you need to understand and you need to know for you to be good or to master this part of made two differentiations, differentiations and partial differentiations. So guys, you can see this is the back of one of the question paper. So guys, you can see during the test they're going to give you this type of question paper and all these formulas, but these formulas cannot help you to solve those questions. So there's some couple of formulas that you need to know also, like this one. You can see yesterday I was busy explaining something, sine minus 1. This is a type of derivative that we didn't do in Met 1. So in Met 1 was busy with this side, cos, and then sec, and then tan, cot, and everything here. But this side was not busy with sine cos minus 1, sine minus 1, those inverse we didn't do. So in this part of DG2, these are actually what you're going to be dealing all along, but they're going to have also some few derivative also they can give you also regarding, but you need also this knowledge, like you need also those simple derivations from Met 1. Yeah, like the example yesterday was solving, it was this one and I was using sine minus 1. So you can see this one they give us in form of integration. I know do you know how to read integration? It's from left, like integration this side is from left to right, but derivations is from right to left. So like that example yesterday, it was sine minus 1. So because we are doing derivation, we're going from right to left. So let me try to take an example. These are formulas that actually you need to know. There's also some transformations that you need also to know. Let's come here by the board here. Like yesterday when I was explaining, I was saying like sine. I was saying sine to the power minus 1 of x. It's same thing. They can write this thing like saying arc sine of x. Same thing. These are things you must know. Same thing. They can say also cos minus 1. It's same thing and arc. And there's some transformations. So guys, you can see we have sine minus 1. If you go back in our formulas here, we have sine minus 1 here. You can see we have sine minus 1. So we have cos minus 1. We have tan minus 1, tan minus 1, cos minus 1, cot minus 1, cos only minus 1. We don't have cot minus 1, we don't have cosec minus 1, we don't have sec minus 1. So you can have you can come across those type of question paper where you have cos or cosec minus 1, cosec sec tan cot minus 1, and those things. So you can see we don't have those formulas here. What I mean, let me come back here. I mean, you can have a question where you have something like cot minus 1 of x squared. Let's say you have a y. You have y which is equal to cot minus 1 x squared, and then they tell you to give dy over ddx. So the derivations of cot minus 1 and x squared. So you can see if you come back in our formula here, we come back in our formula sheet, we don't have that example. We don't have example of cot. You can see this one is cos minus 1, is not cot. So guys, you need to transform this form to you need to transform this form so that you can have that formula on your in the data sheet here, I mean the formula sheet, so that you can apply. But we know we can change cot to tan, but how? So to change cot to tan, like in this case, we can change that y we can change it to 10 minus 1, and then our function now is going to be 1 over, it's going to be 1 over that fx squared. This is how you transform this question. This is how you transform the code minus 1. This is how to transform the code minus 1 to 10. So you can see that, guys, from this side now it's very easy. Now from this side it will be very easy. It's going to be very easy for you now, because we have that formula, we have this, we have 10 minus 1 in our formula sheet. So like, let's take that example. The formula 10 minus 1, we have 10 minus 1. What is 10 minus 1? Is like 1 over a 10 minus 1 fx over a plus c. So we must come back, we must give the derivative. We see the derivative will be fx over f prime x over fx squared plus a squared. But the problem here, sometimes we used to ask question, what is a? Let's come back here. You can see here a is supposed to be, we're supposed to have 1 over a in front here, but the problem, we don't have a, so we have only 1, because I can rewrite, because carry, we don't have anything, we don't have anything here, because we don't have anything, so we assume 1 over a, it's 1 over 1, which is the same thing and me saying it's 1, we have 1. So in our case now here, our a will be equal to 1. Even we check, I'd say that when you have a bracket like this, this is our f of x. This is our f of x. Not this is our f of x, because you have bracket that close everything. This is a function. We have f of x, because sometimes people make mistake and say f of x is 1 and then a is x to the power squared. So it's wrong, because you have bracket everywhere. It's different if you have bracket 1 over x squared like this over, let's say, 3. Now we can say this one is our function, which is fx, but down this one, this is our a. But different, you can see this one is very different, this part is very different, and this part. So now you guys, you can see this our those type of formulas and those type of things are going to deal. Now you can see our a is equal to 1, and then now we can find f prime. So our fx is this one. This is our fx. Let me clean here. Now you can see our a is 1, and our y 10 minus 1. So our fx is this one. And dy over dy of this, dy over ddx, sorry, for this function, for this function, is going to be what? Let's say, because it's tan, I say when it's tan, is going to be what? f prime x over fx, regarding our formula there, everything squared plus a square. So that's the formula from our formula sheet, this one. So now we must find, we have fx, which is this one, this is our fx. We must find f prime x. You can say this function is a type 1 over x square, which is this function. We have v and then prime, which is what? U prime times v minus v prime, times u, times u over v squared. So this, so our u in this case, our u is 1, and then our v, it's x squared. and then u prime is what? 0, because derivative of constant is 0, and then our v prime, it is going to be 2x. And then now you find your f prime by saying f prime x is going to be what? U prime, we say u prime, which is going to be 0, which is going to give us 0, u times v, which is going to give us 0, and then going to be v prime u times u is going to be what? 2x, and then down you're going to have what? X to the power 4. You see, guys, this is our f prime. So we can take that f prime, replace here, and our fx, which is this one, replace here, and then y a is equal to 1, and then we just that's the final answer. But sometimes the question you must transform, make it simplify your function, your answer, because some lecturer can penalize you for that. You can't stop there. So actually I was supposed to explain you this concept, guys, of these transformation formulas that you need to know. I don't know, you have all of them in your